Morning, folks. So we've got a couple of things to do today. The lecture is going to be on Arraylists. This is sort of arguably one of the most useful utility classes in Java and probably one of the most used as well. So we're going to take a look at that, sort of show you how to use them. And if you're going on to CS2, this is something that we cover in a bit more detail, sort of learn about the whys and hows that sort of make this array list actually work properly. In fact, with the stuff that we'll learn today and potentially some in CS2, you could essentially make your own version of the Arraylist class, which is something that I think they probably do in a data structures class for sophomore computer science folks. The other piece of today is, let me pull up the PDF here, is the PA6. So this will be our last one. It's available right now. It'll be due before Thanksgiving, so you won't have any homework or anything over Thanksgiving at all. Like I said, this will be our last one. It's the same sort of normal PA procedure. This is probably one of the more complicated ones that you will do. That you have done over the course of this semester. There's only one part, so it's only a part A. There is no other parts to this. And essentially, you're going to generate a calendar. So the output of the program, after you enter in some values, is going to look something like this. So sort of a standard way that you might flip through a calendar hanging on your wall or something. So the day of the week is going to start on some particular day. So the first day starts on a day of the week. It goes through the correct number of days, and then the next month that you print will start on the associated next day, and then continue on. And you'll do this for the entire year. There's two inputs to this. There is the year, and there is the day of the week for January 1st. So for this particular one, I don't know what year was entered in this output, but I do know that it was the Saturday that was January 1st. So essentially what you do is you allow the user to enter a year and determine, is that year a leap year or not? That determines how many days February has. Then you'll allow them to enter a number. So it's just going to be an int, 0 for Sunday. So the first, if the first day is Sunday, they'll enter 0, 1 for Monday, and so on. So a 6 for Saturday. So in this particular January that's output, a 6 was entered for January 1st. So we got the Saturday was the first day of January, and then it went on through. There is some starter code to this, so we are going to talk about that. So I'll sort of point out a few things related to it. But essentially what you're going to do is you're going to write a method that prints one of the months. That's all it does. It prints one month. Input into that method is going to be the month that you're printing, so a string. So January, February, just literally the word, that the name of the month. How many days need to be printed? So for January, 31 days. For February, either 28 or 29, depending on whether it's a leap year. And the day that the first of that month starts on. So again, for January here, it would be 6. For February, it would be 2, right? We have 0 for Sunday, 1 for Monday, 2 for Tuesday. So February would start on 2 for the first day of the month of that month. So there are methods that are sort of already outlined in the starter code. So again, we'll talk about that in just a second. So the sort of paragraph right here, or the couple sentences right here before the output, tells you that January, in this case, January starts on a Saturday, February starts on a Tuesday, because January ended on a Monday. So the output of this should make sense, but you are going to have to think about how you get your program to do this. So it is a complex program. You're going to have to think about exactly how you print this out. Because notice that if there's only one digit in the day, there's going to be a space before I print the digit. If there's 2 digits, then I print them both out. So little things like that are stuff that you're going to have to think about. So it's a complex problem. It has many moving pieces. There's plenty of different ways to approach it, so you don't have to take sort of a standardized way. But before writing the code, sit down and think about the problem. Take a look at this January month and think about all these pieces. You print the name of whatever the month is, whatever the string is, and then you have a new line. And then it's just all spaces before you get to the first whatever the first day of the month is. And then it's another, and then you have a new line. And if it's a single digit, you print a space, and then the number, and then the space between the days, and then another space in the number if it's a single digit. So it's all of these little pieces that are going to have to fit together. So you're going to have to think about how to go about doing this one. I have a few sort of helpful things here on the second page. My recommendation is write the leap year first. So there's a leap year method, write it first, because it's totally self-contained. You don't have to have anything else right. You can run the unit test, and the unit test will tell you if you got that right. So the leap year won't be too big of a deal. We've talked about leap year stuff before, so you should be able to figure that out. And I think at the bottom of one of these, I think it's the first page, there's a leap year algorithm here that you can use to fill into that method. So do that one first, make sure it works, then you're on your way. Then you're going to go to a method called print month. So just start by printing the name of the month. That's just a string that comes in to the method. Make sure you get the new lines right there. Then just try to print the correct number of days. And make sure that after every Saturday, so after every 7 days that you print, you put a new line. Then make sure that you get the single digit versus double digits in the correct locations so that everything's all sort of lined up. And then the last thing I recommend doing is thinking about those blank entries, the blank days that you have to put in before the first day of the month. After you have 1 month printing out correctly, then you can go to main, because what you're going to do in the main method is you're going to use print month and do it 12 times. So you're going to call print month 12 times, once for each month. When we take a look at the starter code, I'm going to point out one very important thing in print month. All right, and then the last thing you want to do is make sure that you support leap years. So in other words, that just changes the amount of days in February. That's all it's going to do in this program. So you have the unit test for all these methods. You have the unit test for validating inputs. Make sure the user doesn't type a negative number for the first day of the month or a number greater than 6. And make sure they don't make sure, I think it's you don't want to put in you want to make sure that you don't put in more than 31 days, for instance, or a negative number of days. So there's a few sort of things you'll have to validate here. And then I think this checks the entire calendar for 2015. So one of the unit tests is literally checking for if 2015 works correctly in your program. So for the starter code, I'll pull that up and zoom in. There are 2. Looks like it looks like the year is the main thing you'll want to check, and then the January 1st day. So for the user input, make sure that you check that the year is positive and January 1st is between 0 and 6. So you got 2 error strings here that you can mess with. Is leap year is a very simple method. It returns true or false. So you put in a year, and true if the year's a leap year, false if it's not a leap year, and you'll return that back because it returns a Boolean. For print month, this one takes a string that is the month. So that would literally be January or February or any of the other months. You put a start day. This is that day between 0 and 6. And then you put in the number of days that need to be printed. And this is the print. The code that's going to go in here prints that 1 month out all correctly. So everything's all aligned. You have blanks up to the start day, all of that. The key to getting this to work in main and being able to print out the whole year is the return value. It's an int. So it returns, and you can see in the comments here, it returns the day of the week. So that's going to be 0 through 6 after the last day of the month. So you need to return a value after you call print month. So in our example on the PDF, January ends on 1. Remember, this is day 0, day 1, 2, 3, 4, 5, 6. So January ends on day 1. That's the last day that was printed. So the method, print month, after it prints January, it returns a 2 because that's when February starts. That's how you can tell the next call, the next month that you want to print, which day it starts on. So January ends on the 1st, day 1. February starts on day 2. So that's what that little piece of this method does. And that's going to be the key to getting the whole thing working properly. Return the day of the month, the day of the week after the last day of the month. Then main is going to do all of the input, the day of the week that January 1st falls on, and the calendar year. And then it will call this method 12 times. And of course, February, number of days, depends on whether or not it's a leap year. So do is leap year first, then figure out how to print the month, and then go into main. And just at first, you can just sort of copy 12 calls to this in and figure out how to deal with the int that comes out of this and sort of where it needs to go, and then put in the leap year stuff. So there's plenty of ways to go about this. The hardest part is going to be print month, because you're going to have to think about, all right, how this stuff is going to be printed, where do I need to put new lines, all of that kind of stuff. So it is really a formatting thing that you're going to be doing. You will need to have loops. So there's no way to get around loops here, because you don't know ahead of time when the start day is going to be for each individual month, and for February, how many days there's actually going to be. So you will need to use some loops that deal with things like start day and number of days. So that is PA6. That's the only part you have to worry about. There's no other parts to this. So that'll be due basically before Thanksgiving, essentially next week. So any questions before we go on to the Arraylist lecture? All right, so like I mentioned at the very beginning, Arraylists are probably one of the most useful, or sort of arguably one of the most useful utility classes that Java has to offer. Most languages, most sort of high-level languages, most sort of OOP languages have something like this. In a language like C#, they're usually just lists. In a language like C++ or something, there's various implementations that sort of do the same sort of thing. And in reality, after a class like CS2 and potentially data structures, you could, in principle, write your own version of this to do exactly what you want to do. So there's nothing sort of magic when it comes to array lists, but through the course of today, you're going to see how useful they can be. So the arrays that we've worked with so far are static in size. When we create them, we'd say something like int array A equals new int, and then you'd put in 100 elements. So you'd say new int 100. I can't change the size once I've done that declaration. The array is 100 in size. It'll never be smaller. It'll never be larger. There's always 100 elements attached to that array. So if at some point I realized that I have 101 elements, or I needed to add an additional element to that array, I wouldn't be able to do it without creating a brand new array of 101 elements and then doing some copies, and it would be sort of a lot of coding work for me to deal with. This is where array lists shine. So if you hear somebody talk about a dynamic sized array or a dynamically sized array, that's what an array list is. It allows you to grow and shrink the array as necessary. So it contains a bunch of methods, because an array list is a class. It contains a bunch of methods that support this operation, to add more elements or to remove elements. That's where the actual power of array lists come in. And really, anywhere where you use an array, a regular array, you could use an array list. It's not always necessary. Sometimes you already know that I only need 10 elements. I'm never going to need more, never going to need less. And a regular array works perfectly fine. But if you don't know ahead of time how many elements you're going to need in your array, you could either make your array super large and hope that it's going to be large enough for whatever your program's doing, or you can use an array list. So that's sort of where array lists shine. Now they have a little bit of new syntax. And this new syntax is something that you learn more about in CS2. You learn exactly sort of what it is and how it works and all of that stuff. So for now, just sort of take this as it's a new syntax. We have to have it, and it's how array lists work. So pull my annotations. So to create an array list, it's just this. It's just array list, like this, and then this new syntax thing, which we'll talk about more in just a second. Then a name. So whatever you want to name your array list, so similar to all the other variables we've done. And then new array list, that new syntax, and parentheses. This, remember, is the constructor. Because this is just an object, just like other objects we've messed around with before. The new syntax, though, it comes from this idea of a generic class. And again, in CS2, that's something that we'll talk about later on. You put a type in here, and that's going to be the type of elements in the list. So if I want an array list of, let's say I was working on a card game program. If I want my array list to contain a list of card objects, then I would put in card in here. It would be an array list of cards. Or you could have an array list of just regular numbers, just like you would for a regular array. So I could have an array list of integers. There's a slight difference in how we deal with like ints and doubles and stuff in an array list, and I'll get to that in a second. But you can have an array list of any type. So whether it's numbers, whether it's more complicated objects, you can have an array list of strings or of scanners, whatever type you want can go in between these angle brackets. So array list, set of angle brackets, whatever the type is. And then the name, new array list, the type again, and then the parentheses for the calling of the constructor. Array list comes from Java util. So you do have to import array lists. So just like we import scanner and all of that, array list is one of those things that we import. For primitives, so that's your int, your boolean, your char, your double. Technically, those cannot be types. Those are not types in the sense that they would go into the array list angle brackets. So your regular sort of primitive types here, you cannot put that in those angle brackets. So what you do is you write them slightly differently. They always start with a capital letter and they're fully spelled out. So char would be character with a capital C. If you want an array list of integers, in those brackets, those angle brackets, you put integer with a capital I. So these are the types you would use. Technically, they're a wrapper class around the primitive type and all that, but that's not important for using it. Just know that if you want an array list of doubles, you got to use double with a capital D in those angle brackets. That's sort of the main thing to remember for the moment. All right, so if I wanted to create an array list of integers, this first line, this is how it would look. For doubles, for strings, strings are already a type. They're already a type with a capital S, so you just put that in. Any types you want. Again, scanners. If you created your own cards, you create cards, whatever type you want to put in here. So this would create those array lists. There's two concepts that are important for understanding what's actually happening in the background. What is the array list actually doing? The two properties are this. The size. So that's how many elements are in the list. When you first create an array list, there's nothing in it. It's zero. The size is zero. It's empty. And you have access to that size through the size method and a true or false variable, a true or false method named isEmpty. So if you ask if array list is empty, so whatever you've named your array list, so A, for example, if A dot is empty. It'll give you true or false if there are any elements in that list. Size is going to be the most common one that you mess around with. So you'll say a.size, and that'll tell you how many elements are in the array list. Very similar, basically exactly the same to your irregular array dot length. It's the same thing. The other variable, it's one that you don't actually have access to. It's the capacity. You can't directly access this, but you can sort of infer what it is. This is the size of the internal array. And we're going to talk a little bit about the internal workings of array lists today, just a little bit. When you create an array list, by default, this is 10. So the size is 0 when you first create an array list, but the capacity is 10. And this is where the interesting inner workings come in. And this sort of knowledge here and the sort of picture I'm about to draw for you will potentially could lead you to writing your own version of this. An array list is just a regular array. It's a regular array that we've been using. But it's only partially filled. So the capacity may be 10. So say the capacity was 10. And the size, maybe I added a couple elements to it. So maybe I added an 8 and a 7. So I have this sort of partially filled array that's being maintained internally in the array list class. And when I add an element, say I added a 6 here, the size would go up to 3, but the capacity is still 10. So I only actually ever access in my code, I only ever access the first 3 elements because that's the size. The rest of these elements here, they don't matter, they're just empty. So that's why I can easily add more elements to my array list, because it's just an array that's larger than what I'm currently using. So from that, you can probably imagine a way to sort of write something like this yourself. You may not necessarily be able to do it right now, but you can probably imagine that, you just have sort of a partially filled array that you're keeping track of a variable called size. And that's it. So this is what's happening behind the scenes. If you get down to where your size and your capacity are the same, so say we have our array here, it's all filled up, I got a bunch of values in here. If my capacity is the same as my size, if I want to add a new element, I need more actual array to do it. So that's something we're going to talk about here in just a second. So all of these mechanisms going on behind the scenes is what gives you this flexibility to add and remove elements from your array. And sort of it's all sort of hidden. That's sort of the OOP sort of style, sort of hide the details and just expose a few things like creating an array list. Hide the details, expose just a few methods, and have the user not worry about exactly how it's working. All right, so I'm going to go over to Eclipse, and we're just going to create an array list real quick. And I'm going to show you a few ways to sort of add stuff to it and print stuff out related to an array list. So if I go over to my Eclipse, just a blank file, I'm going to create an array list. And we're going to have this just be an integer array list. So we got to spell out integer. And I'll just name it A. And this will be a new array list. I need the brackets again, and I'm going to put in integer. And then I need to import array list from Java util. Make sure it's there. So now I have an empty array list. So remember, this is size equals 0, capacity equals 10. So if I were to print out, the, let's see, size, and we'll print out an int and a new line. If I were to say a.size, so this is how I print out the size of the array, my name of my array, dot, and then the method size. This should tell me 0. So it's empty, nothing in it. But as soon as I start adding integers, I need to make sure to add the appropriate thing. So I'm going to add some integers to the array. So I can say a dot, and the method to add is literally just add. Then I can add whatever I want. Say I want to add a 10. If I print out the size again, it was 0 to start with. Now it's 1. Now remember, the capacity is still 10. So after this line, or after I do my add, but when I print here, this will say size equals 1. The capacity is still 10. So what just happened in, pull up the annotation stuff again. So what just happened was that I have this big old array, and I added 10 to it. So my size is 1. My capacity is 10. So I have this 10 element array. I'm only using the first element. And I can keep going. I could just keep adding more and more and more. So we can sort of do this same thing again. And I can add, say I want to add a 5 this time, print it out, and size is now 2. So I'm using 2 elements in that 10 element array. Again, the capacity is still 10. Now, let's say we did this a few times. And let's say we got to the point where we had a size 10, capacity 10. So I wanted to add a new element. Say I wanted to add, I don't know, a 9 here. This would be over 10 over the cap. So internally, the array list sees this. It sees that the size is 10, the cap's 10. If I want to add a new element, I got to change the cap. On the next slide on the presentation, I'm going to show you this. I'm going to show you sort of the outline of how this works. What'll happen is that the size will go up to 11 because I add an 11th element, and the capacity will change to 20. So I'm going to show you how this happens in just a second. And then that continues on. I could go up to size equals 20, and then the capacity will actually double to size 40, or to cap 40. And then I could keep adding more and more. So it doesn't matter how many elements I add to this, there will always be room to add more, unless I run out of memory on my computer. So that's the power here. You don't have to know ahead of time how many elements you're going to need, because the array list will size itself and adjust itself appropriately. Okay, so any questions so far about this sort of usage, this sort of printing out the size, adding elements? Any questions you guys have about that so far? Okay, so the resizing behavior. So whenever you add an element so that the new size would exceed that capacity, so if you would go to 11 when your capacity is only 10, then the array list resizes. So the basic idea is this. Internally, in the array list, it creates a new array of the new size. So let's say your old size, your original capacity, was 10. So it creates a brand new array of size 20, double the old capacity. So it just creates a brand new array. So I have my old array, and then I have my new array. So this one's all full of stuff. This one is all empty, this new one. So this would be the old one. This would be the new one. Then it goes through and does a loop. It's going to loop through every single element of the old array and copy it into the new array. And then this little last line here is just a rename. So it essentially gets rid of the old array, and this is now the list. So we have twice as much space as before. Our size is now here, and we've got plenty of extra space to put new stuff. So that's the process that this goes through behind the scenes. Every time you wanted to add an element that would exceed the old capacity, it creates a brand new array, doubles the size, copies all the old stuff into the new array, and then gets rid of the old array, forgets about it. So that's how it works behind the scenes. And that's why this is relatively easy to code your own version of, because the algorithm is very simple for how this works. At least the sort of basic operation of how this works. You don't necessarily need to know how this works to use it. But in a class like data structures in sort of sophomore year, you'll sort of learn more about this sort of stuff. You'll learn about a lot of different types of data structures, but this is sort of one of the ones that you will have used the most or be the most familiar with from a class like CS2, for example, from actually using it. Now that copying behavior, that can become expensive. Think if I have a huge array, maybe my array is like a gigabyte in size. Every time I have to increase the size, I have to copy a gigabyte into a new array and then get rid of the old one. So if you know your array needs to be large, then you can call a function called ensure capacity, and it will automatically make the array that large to start with. The constructor, so that empty constructor we use, just a 2 parentheses after we do the new array list, you can also tell it to have an initial capacity larger or smaller than the default one as well. So if you know you're going to have 1,000 elements, then you may as well use the constructor to set the initial capacity to be 1,000 elements. So this is something you don't necessarily have to worry about now. We're not going to have any sort of computational bottlenecks or anything related to the programs we're writing, but it's something that can be helpful if you're creating a lot of array lists or you have a lot of these sort of copies and stuff that need to take place because you're constantly increasing the size of the array. So it can have an impact for sort of a CS1 and CS2 style class. Probably not that much. It probably wouldn't be noticeable if you use this style of capacity stuff or not. All right, so it's all fine and good to add elements, but we should be able to get the elements as well. We should be able to access them and use them like a regular array. So to get the access of a variable, you use, or get an access of one of the variables in your array list, you use get, and then the index. So almost the same as a regular array, we still use an index, but instead of the brackets, instead of our name and the brackets, we would use the name. We would use the name dot get, and then the index. So it is slightly different, a little bit more typing, but of course you have that flexibility, so it's certainly worth using. If you want to change the value of an existing element, you use set. So you would say set, you'd have whatever your name is, a.set, whatever the index is, and whatever the new value you want to change. That index too. So you have this get, you've got set, and we've got add. So those are sort of our three that we want to use when we're sort of modifying the array in some way. So as an example here, we add hij to this character array list. I do a set to set element 2. So this is element 0, element 1, element 2 to an exclamation point. So in this array list now, we sort of draw it out, we're going to have an H, an I, and an exclamation point after this line. And then there's a print that's going to get index 0, get index 1, get index 2. So this will literally say H, I, exclamation point in the actual print. So again, there's not a lot of difference here between using a regular array and an array list. It's just you have to get used to the methods that you use to get, set, and add elements. Because you can enter an index, so because I can put any number in my get or in my set, you can still get an out of bounds error. In this example, if I try to set or get index 3, then it will say index out of bounds. So if your index is less than 0, or it's greater than or equal to the size, then you will get this index out of bounds exception. So that's still the same sort of thing you would get with a regular array. So this isn't going to protect you against potentially getting using a wrong index or something. It will still give you that particular error. All right, so let's write a quick program that uses this. So we're going to ask the user for a list of integers. So we've done stuff like this before. Get a whole list of integers and then, enter a value that's like not an integer or something, or enter a negative value or something. We've sort of done that before. So we're going to do that. We're going to write a program where the user enters a list of integers, no limit. Not going to be 5 integers or 10 integers, just no limit. And we're going to output the sequence of numbers entered in reverse squared. So 1, 3, 10, 12, 144, so that's 12 squared, 100, 9, 1. So the reverse order is the part that we need the array for. I could easily just square the number, print it out, and forget what the number was that the user entered. But to do it in reverse, I need to keep track of all those values so that I can print it out in reverse order. So that's why we're going to need the array list here. So, yeah. So let me open up the code here. I'm going to delete the array list stuff we had. And we're going to need a scanner, of course. And we're also going to need that array list. So let's go ahead and start with that. So say scanner input, new scanner. Save that in. And we'll do the array list as well. Array list, these are going to be integers. And I'm just going to call it A like we had before. This will be a new array list, integer. And I mentioned we could, in the parentheses here, in the constructor, we can put a number. I could do something like put a 100 in here. This will mean that our capacity starts at 100, not at 10. So by putting a number in here, at least by putting just a single number in here, we can adjust what the capacity starts at. So 10 is just fine for this example, but if you needed to change that, if you knew you were going to have 100 elements in here, and it might be 100 or more elements, but you're never going to really have less than 100, then yeah, setting it like this, perfectly fine thing to do. I'm going to leave it empty, which gives me that default of 10. And I'm going to make sure that my scanner is imported. So I need my array list and my scanner imported here. All right, so I'm ready for this sort of entering of the numbers. So let's do that. Say system out printf, and let's say enter. We'll probably say enter. I don't know. Enter integers. Now, the question they might be asking is, all right, how do we know that there's still integers to read in? So I'm going to use one of those has next methods. If there's another integer to read, then let's do it. And I'm going to use just a while loop to accomplish this. So I'm going to say while input dot has next int. This gives me a true or false. Is there another integer to read? So does the input have another int to read in? It should be has next int. If there's another int to read in, then let's do it. Let's say a.add. So we're going to add to our array list, and we're going to read the integer in. Has next int just checks is there an int. So I still need to do my input.next int like this. You could separate this into 2 lines if you want to as well. So I could say something like int value equals input.has.next int, and then I could add value. That's a perfectly fine thing to do as well, but you don't necessarily need the value here. You could just put the input.next int directly into the add. When there is not another int left to read in, then we can print it out backwards squared. So that's why I want to use a for loop. So I'm going to say for int I equals a.size. But a.size is, so if I put in 10 numbers, for example, a.size would be 10. But that's over my number of indices. Remember, index goes from 0 to size -1. So I need the -1 here. If I put in 10 numbers, I would start at 9, the last index. And then I need to go to, I need to keep going. I needs to keep going while it is greater than or equal to 0. So we're going to drop down with an I minus minus. So we start at size -1, say we start at 9. While I is greater than or equal to 0, we continue this loop, and the I changes, gets smaller every single time by 1. Then I can do that print. So I can say, let's just do a %d and a space. And the thing I'm going to print out is a.get I times a.get I. So I'm doing the squaring, and I'm using get to grab the particular index. And then I think if I want a new line at the end of my program, then I would just put a new line in at the very end here. So I run this, I can enter a bunch of numbers, and notice if I press enter, nothing's happening here. As soon as I enter something that's not a number, then it'll work. You should also be able to do like Control Z or something as well. Some of that can be a little finicky using the Control Z on it. Sometimes you got to like change the focus of the window and stuff. But as soon as you enter something that's not an integer, then it will stop. And it can't be white space either. So that's something to consider, because white space will just be, it's looking for the next thing. So I think I could do the Control Z potentially. There's some other control one you can do, and I always forget what it is to stop something like this. So let's try it again here. And so it's not in it, and there we go. So that's the idea here. Create an array list, read in as many values as we want. Doesn't matter. We're always just going to keep increasing the size. So here I did 10 exactly. So if I added another one, then it would trigger all of that resizing behavior that array lists have. But it doesn't matter. I'm not going to know anything that's sort of going on behind the scenes. I just know that I can continue to add elements. And then when I want to get the elements, it's just array, whatever your array list name is, .get, and getting the size of the array list is easy as well. So that's the sort of overall idea of array lists. Now, I mentioned you could not just expand the size, so not just keep adding more elements, but you could also remove elements as well. You could add or remove elements of this array list. So in our slides, I do have sort of a sample answer here. For removing elements, you can erase them with a few different methods. You can use remove or clear. Clear gets rid of everything. It clears out the entire array. The capacity stays the same. So if the capacity was 1 billion, the capacity stays 1 billion. It's just now the size is 0. So you're not using any of that array if you want to, loop through it or something. Then you have remove. So you can remove a particular index. So you put in whatever index you want, 10th element, and it'll remove the 10th element. Or you can put a value. Let's say you have an array of strings. And in there, you've got a couple of greetings. You've got hi, and you've got hello, and you've got hey, whatever. So something like this inside of your array list. If you say remove, and for the value, you put in hello, it will find hello in your array and remove it. So you don't have to put an index in here. If you know the index, great, you can use it. But if you don't know what the index is and you just want to remove a value, then you can do this as well. This would completely remove the hello. The downside to this one is that it only does the first occurrence. So if I had another element in here, if I had a 4th element that was the same, that was hello, this. Removing the value, hello, would only remove the first one. It will not remove all of the instances of hello. So I would potentially have to call this multiple times to remove all of the instances of hello. I have to call remove hello and remove hello to get rid of both of them. If the list was changed, so in other words, if you removed something, this remove function actually returns true if you successfully removed an element of the array. So there is ways to check if you actually removed something or not. The downside to the removal, And this is something we get into a little bit actually in CS2, other data structures that are actually better at this. The downside to using a removal is that every single element, and this happens behind the scenes, every single element has to get copied up one. So if I remove hello, I don't just want a blank element here. That wouldn't work very well in the rest of my code. So hey would get moved up by one, and then the second hello would get moved up by one as well. So imagine you have a billion element to list and you remove the second element. Now you've got almost a billion elements that need to be copied one after another up one location. So go here, move up. Next one moves up. Next one moves up, and so on. That can be slow. So if you have a really large list, you want to try not to use remove unless you absolutely have to. So there are performance considerations when doing some of these things. Again, in a CS1 or CS2 class, you're not going to notice that. But potentially down the road, if you notice some sort of weird performance issue when you start using Arraylists in some complicated program you're writing, it could be related to adding to the array list and having that copy happen when it goes over the capacity, or something like this, a remove, a large array, and you're removing from the top of the array. If that's the case, then picking other data structures is usually a good idea. Trying to find one that does this in a better way. And we talk a little bit about those. So I give you some sort of basic ideas of how data structures, or how some of the simple data structures work in CS2. Sort of which ones to pick when, for instance. All right, so there's also this trim to size. It reduces the capacity. So I mentioned that clear changes the size to 0, but the capacity is whatever it was before. So if I had a billion element array and I did clear, the size gets reduced to 0, but the capacity is still a billion. Trim to size, which you can use anytime, you don't just have to use it when the size is 0, it will reduce the capacity to the size. So if you've got 10 elements in the array, you do trim to size, the capacity gets trimmed to 10. So in this particular case, if I did a clear and a trim to size, the capacity is 0. So it'll copy over and make the sizes, make the capacity the same as the size. So that's just a couple of other ways to sort of mess around with this sort of capacity thing, especially if you start removing elements. If you remove elements, it could be useful to do a trim to size. All right, I have a couple of sort of examples here. There's not a ton going on here. It's just an example of removing elements. So creating an array list, adding hello to the array list, printing it out, removing all the L's, trimming it to size, and printing it again. So that's really all this is doing. There's a couple of functions in here that do this. So like remove all. So it's going to remove all of the, in this case, remove all the characters that get entered in, and then the print. There's kind of a different print here. We're not going to talk about it too much, but if you've seen sort of prints like this before, this is what's known as a for each a for loop rather than sort of a regular for loop. I talk more about that in CS2 because the reason this works actually depends on some of the stuff that we learn in CS2. The reason you can do this with array lists. It has to do with how array lists are created. So if you want to take a look at this, you can certainly code this up, but it's really just doing some removal stuff. So sort of showing some of those remove actions. All right, so the take-home points for this is that array lists are useful. They have a lot of methods that allow you to grow and shrink the array. You don't have to worry about the stuff that's going on behind the scenes. So you just use it as is, and there might be some performance implications, but for now, it's not going to really be a big problem. There's lots of aspects that we don't cover. Things like the array lists are iterators and other stuff like that makes them useful in a lot of situations. But those are things that we'll talk about more in CS2. So anywhere for sort of for the rest of CS1, of course, for CS2, anywhere you think that an array list could be useful, feel free to use them. They're going to give you the same capabilities as a regular array, just a little bit different usage, and a little bit more flexible whenever you need that flexibility. All right, so next time, so on Thursday, we're going to do a little sort of OOP project, and it's going to I sort of call it this sort of critter OOP project. It'll just be a lecture long, most likely. We might span it out into two, depends on sort of how far we get. But I want to give you some more insight into how this sort of object-oriented programming stuff works, because that's a big focus in CS2. So if you're going to CS2, this will be useful. If you're not, if CS1 is sort of where you stop for your major, it's still useful to see this OOP stuff, because that's basically how any program you write, whether it's Python or JavaScript or whatever language you're using, it's typically the sort of the standard way that you write programs in sort of an object-oriented way. We talked about PA6, so again, that's available now, and it's due next week before Thanksgiving, so that will be the next Tuesday. All right, so that is all that I have for you guys today. So I will see you on Thursday.
Thank you, Professor.
Yeah.